Companies in the oil and gas, chemical, mining, construction, and energy industries are using RFID technology to improve operational safety and efficiency, as well as improving financial results. During this virtual event, you'll learn how the technology can be used for asset tracking, personnel safety, and equipment maintenance, as well as to speed production and shipping processes in harsh and complex environments. Now, I'd like to introduce our first speaker, Ed Nabrowski, Chief Solutions Officer, Omni-ID. His session is entitled Top 10 Best Practices for Deploying RFID in Harsh Environments.
Thank you, Deb. I'm going to try and take control here. Excellent. Again, we're very pleased to present today and to speak about this important topic. It's what we live every day, and we're looking forward to going through these topics. A little bit about us. Omni-ID is the #1 supplier and manufacturer of UHF RFID tags for this harsh industry. A little bit of our background. We are the original patent holder for on-metal RFID and developed many of the early tags and concepts for mounting directly on and in metal. We've done a number of industry firsts for range as well as frequency response, a lot of work with ceramics, and of course one of our big lines right now is the first visual tagging system for industry. This visual tagging system, as you see in the picture on the right, incorporates e-paper screens directly into the tag, allowing a true Internet of Things implementation that gives feedback to users as trackable tags go through the system. So we're an innovative company that pushes the boundaries and is very much in this space. Our agenda for this presentation, rather than get into a lot of the in-depth technology that we use, both in materials and adhesives and for absorbing shock, we thought we'd talk about applications and talk about 10 key applications that we face in rugged environments. Going through applications often spawns ideas. We hope it will give you thoughts about your own application and how to handle them, and we'll try and point out key issues in dealing with each of these applications in the harsh environment. So first off, before we get into the applications, there's a key step here that almost goes without saying, but I didn't want to not say it. Identifying requirements is absolutely key. Many people ask me, why do you make so many different kinds of tags? Omni-ID literally has thousands of tags, many that are on catalog and many off-catalog tags we make specifically for different customers. And the reality is that one tag doesn't fit all, and one use case doesn't fit all. You get tremendous benefits from really understanding the use case specifically, and both tuning your RF, but also your materials, your adhesives, your temperature and chemical resistance. All of those factors can make a tremendous difference in the application. And frankly, if you're doing any major implementation where you're counting on getting that data reliably, close to 100%, you'll want to have a very close look at requirements to make sure that you've got the exact right equipment to make that go. There's no substitute for bringing the business people, the integrator, and the supplier together to do a thorough requirements review before you start your program. Those professionals can share ideas, can have a close look, can do some testing, and ultimately get you the right solution that you need. Omni-ID especially thrives on doing many, many custom implementations, from new molding materials to new RF structures, and it really is true that there really is no major application that hasn't required some kind of alteration or customization to really optimize it. So get your people together, think about durability and attachment method, think about the environmentals that you're going to be putting your assets through. Think obviously about the read range you're trying to achieve, sometimes the write range you need, and the reliability you need on those reads and writes, so that we can design the system in a way that you'll get that high reliability at the ranges you're going to expect to have in your application. So each of these applications, of course, will have had that step happen. But let's talk about some key applications, things that we've seen and experienced in an attempt to spawn some ideas for you. A key area that is really harsh is yard management. We deal with yards in many industries all over the world, from heavy, large capital construction to oil and gas and energy. There's a lot of inventory out there in wide yards, and this can be a real challenging problem. Think about, how do I identify and locate a unique individual asset within a massive yard? We recently did a yard of 25 square miles, and you're sending a crew out there in a truck to go and pick up one pipe spool. I need to find that exact pipe spool. and there might be 100,000 pipe spools spread over 25 square miles. That's a real challenging application. The last thing that you want to have happen is have your tag fail, your ability to identify it fail, so that you can't find that asset. There's a lot of software and infrastructure constraints as well to talk about that to make sure it works. But the key is to make sure that you at least have the item tagged and make it readable. So yard management, thinking about that application, we have to deal with sub-zero temperatures. The problem with this particular yard is it would have a lot of snow and a lot of ice. So can the tag survive and still beacon at that very low temperature? Have we picked the right frequency to be able to penetrate through the water and the ice that happens? And here's where lower frequencies really help. In this case, these materials are also being shipped all over the world, and so they're coming from different suppliers. So do we have a global tag? When we say global, there are different frequencies in different regions. And so it's important that a tag can support those different regional frequencies to be read. Again, many tags will be only regional in their scope. They're tuned for a particular frequency. So being able to have a global tag allows it to pass through your entire supply chain. In yard management, though, probably the biggest thing that you're looking for is distance. You've got very large yards, and you're trying to minimize the amount of infrastructure or the number of sweeps that you're going to have to do to take that inventory. So think about, how do I get the longest distance? Usually that means an active tag. With active tags, you can get hundreds of meters of read distance, especially if you go down to lower frequencies, like 433, a very popular frequency, 433 megahertz for outdoor environments. The lower frequencies also allow you to penetrate that ice and snow much better, and also even human bodies, where you've got workers out there sometimes blocking signals. So going to a lower frequency, a long-range tag is often appropriate here for yard management, and in this case certainly was. Yard safety for employees is also a consideration in this application. They are part of your infrastructure, and tagging those employees and being able to see them as they go through your yard is often a key piece, a key asset that you're looking for. So choosing a system that can tag both the assets in multiple ways and tag your workers is an important consideration in yard management. We'll flip to the second application, high impact. And sometimes this can be in the yard, but we've seen the same thing in some really tough environments where containers are crashing together, pipes are crashing together. Certainly on oil rigs, we've done a lot of work where we've got slings hauling materials up to an oil rig, and there can be a lot of impact in the loading and the unloading feature. It's really important that you consider your use case and think about high impact cases. Be as specific as possible, or scientific as possible, I guess would be the right way to say it. We had one application with a pipe manufacturer where we were putting these tags on pipes, and the test was a sledgehammer test. And it really varies on which sledgehammer you use, and more importantly, which worker is wielding the sledgehammer, on how much force is being exerted on that tag. And it's a great way to test, but more scientifically starting to create a specific pendulum or drop tests, being able to put a certain amount of force, putting it on machines. Again, at our company, we have a number of great test jigs. You can see some of the pictures that our tags are going through here for both pressure, for shock and vibe, for torque. Important when you're thinking about any kind of impact that you work with your suppliers and your integrators to define it, to understand what your worst cases are, and then test aggressively for it. Don't be satisfied with a tag that can't stand up to your worst case scenario, because that's exactly what's going to happen, and then you'll lose data and ultimately lose material. Better to test up front and have a rigid set of requirements that you know you're going to need to meet, and make sure that your suppliers can meet them. All right, the high impact also impacts your form factors. Obviously, the larger that tag is, the more it protrudes, the more impact it's going to get. So thinking about how to make it slimline, how to make it fit into apertures. We had a great application on a container where the container was ribbed, and we made a tag specifically to fit between the ribs of the container to shelter it and to prevent it being impacted. So don't be shy about looking at your application and saying, I'm going to have a lot of impact here. Work with your suppliers to design something that will specifically fit to minimize that. This is always a fun one. We have a lot of questions about explosive environments, partly because of the energy industry we work with, but also the military industry we work with. We do a lot of applications around the world with different militaries. And especially when we get into active tag systems, but even into passive tag systems where we have a lot of readers and antennas and cabling around, there's a great requirement to make sure that we are explosive certified. There are certification bodies that you can rely upon, not mentioned here on the slide, but something called HERO, which allows you to be certified for these munitions type applications. More commonly, we look at ATEX, especially in the European markets, and now IECX as a new standard coming through there, and the Class 1 Div 1, Class 1 Div 0 applications that we see more commonly in the United States. Making sure that you've got products that are certified means that you will know that they've been tested in those environments. Be very careful when you look at those certificates. When you look at an ATEX or a factory mutual certificate for Class 1 Div 1, it'll be very specific about the gas group that they're certified for, the environment that they're certified for. All those need to be matching your application. If they have done that testing and your supplier has those certificates, you'll be able to get that test data. And it's good to look at the data yourself and understand what the boundary conditions are. For our company, of course, we not only certify, but we also do limit testing. So we will pass the minimum standard to get the certificate, but we'll also test the failure and show where that failure point is. I know as an engineer myself, I like to see a big gap between passing the minimal standard and where I actually fail, where the limit is. And so understanding those can help you have assurance in your environment. It also helps you in meetings internally when you're trying to overcome naysayers who think it may not work to show what those limits are. So look for original certifications, look for test data, and don't be shy about asking your vendors for their test data to understand what's been tested and how it will comply. Form factor, both in location and placement, could be a big issue here too. I mentioned that one out of this list because when you're thinking about weapons or vehicles or mobility, how you place it and exactly where you place it makes a huge difference in its usability and also in its exposure to some of these explosive environments. In the case of the weapons tags that you see on the right-hand corner, we spent months with users tuning exactly where that tag would be placed and exactly how it could function without impairing the weapon or the user of the weapon. So placement is crucial in these environments. Temperature is one of our favorite ones. Everyone has to deal with this depending on their environment, and it's a common environmental problem. Tracking assets through high temperature processes, many people think is not possible, and often will exclude that in their process, thinking they can't get a tag or an ability to track through that environment. We've made a lot of progress in this area in the industry by and large. Certainly surgical instruments, as you see in the top right-hand corner, is a key area here. We've done a lot of tagging of surgical instruments here at Omni-ID and have multiple formats of tags, some off-catalog that are not even out there being shown publicly, but that are able to survive tremendous environments. We test up beyond 225 degrees Celsius for 500 cycles, and when we say cycles, we take it down from freezing all the way up to 225 and then back down again continuously, and are achieving great results of 100% passes on the tags we ship into that industry. So it is very, very possible and very reliable now to achieve that kind of temperature performance, where previously it was very difficult with the thermal expansion that would happen in materials. So surgical instruments are a great example, a great application of that you can think of being in sterilization chambers. Another great application, as you see down the bottom right, that is a tag we call a drill pipe tag. We do a lot of work in oil and gas, and drill pipes are a really important trackable asset. These pipes, of course, can wear out. They need to be maintained. They need to be certified. And as such, they need to be tagged. But the environment they go into is very difficult, both from temperature and from pressure. So developing a tag like you see in the bottom right, where it's protected, and you're able to thread it into an aperture or epoxy into an aperture and have it become a permanently mounted piece of the equipment, is typically how we deal with those kinds of environmental situations. We've done the same thing on pumps, on valves, on harsh environment equipment that needs to have high heat, where we've embedded it directly with a great thermal casing directly into the pipe or the asset itself. So don't feel like it's unachievable. If you have an application like that and you've worried that a tag can't be designed to work in that environment, then cast those doubts aside. There definitely are products, and from us specifically, that can do those kinds of applications. Global versus regional is always a question. There's a lot of regional products, and when we say regional, as we mentioned before, in UHF, RFID especially, there are two main frequencies, the ETSI frequencies in Europe that are 868 megahertz, and then the American or FCC over here, a little over 900 megahertz. And tuning to those two frequencies is often challenging within a structure, especially a small structure like this put into a molded environment. But few companies do offer bimodal tags, or tags that are tuned to both frequencies. We do as well, and that allows you to have a global tag. For something like a pipe tag, drill pipe tag, drill pipes can be used in one area and then shipped to another part of the world. And when it's in that other part of the world, it may be on a different frequency. And by regulation, by law, you won't be able to scan it at the frequency it was tuned to regionally. So sourcing a global tag for your application can be really important. And don't forget about that. Sometimes we forget that those different frequencies exist. The other thing that's important here in high temperature is adhesives. Sometimes you'll look at the tag and think the tag can survive, but the adhesive is a huge problem. The thermal expansion that you achieve, even the degradation over time when you cycle frequently, can break down a lot of adhesives. We have full-time materials engineers, material scientists that do this for us, and we spend a lot of effort on adhesive, probably as much as the tag in some applications. So don't treat it as an afterthought and assume that you can get something just to stick and make it stay there. Counsel with your integrator and your supplier up front. Define exactly what you need to be able to stick that on, and then test, test, test. There's no substitute for testing and validating, specifically in your environment, because there's a lot of gotchas here. It won't help you that you have a great tag if it falls off, and it won't stay with your asset. Another difficult use case, especially in challenging environments, is high memory. In many cases, we're not just tracking it as a license plate. We're trying to encode data into the asset itself. This can happen for compliance reasons. We mentioned before valves and pump stations that occasionally are going into government projects, and we need to comply with various regulations there in encoding information for maintenance and for anti-counterfeit. Or it could be for your process, where you're encoding process information directly into the tag. Tracking assets through a process like that requires more memory than a typical tag. Most tags are going to have up to 128 bits on them, but 128 bits will just give you that license plate ID and won't allow a lot of user information. So consider your memory requirements. How much do you really need? How much will you use? How often will you rewrite it? The tag we show on the right-hand side was designed for carriers, goes into different skids and lids and carriers into manufacturing plant floors primarily. And it has up to 1 million cycles that we can write that memory, and up to 64 kilobits. 64 kilobits is a lot for a UHF tag, but it is possible and obviously deployed here in this format. So if you're thinking about a lot of memory, realize that things have come a long way, and UHF tags can now have quite a lot of memory encoded in them to allow this kind of process step. Think about how much memory that is. Think about the Declaration of Independence and the number of words that are in there, and all of the signatures that were attached to that great declaration. We can encode all of that, a full Declaration of Independence, into this tag, so you get a sense of how much data that is for your process flow. Again, even with high memory, on-off metal makes a big difference, and so you have to make sure that you are tuned properly for whether you're on or off metal. Being able to be regional or global. We talked before about that and how important it is. In this case, it's interesting the way that it was done. We did a cross-polarization technique so that there's one antenna tuned for the EU frequency at 868 running vertically, and there's another antenna tuned for 915 running horizontally. That allows you to control the frequency you're tuned for just by the orientation of the tag, or more importantly, perhaps the orientation of the antenna. If you're going to use a linear antenna, you can orient it that way to be able to read the tag best. But at least it allows you to have a global footprint for both. This is, again, a key consideration, especially if your carriers or your devices are going to be traveling around the world and you're going to pick up the data that you've encoded in that high memory in different places around the world. So think about your process, think about the global side of it. And again, the environmentals and exposure, that it can be sealed and encased. This one's got a polycarbonate case that's completely sealed, and so it's rugged and able to withstand any kind of environment. I've gone backwards, forwards. This is always a fun one, interference in noisy environments, especially in our active tag installations where you're dealing with larger distance. This is a real key consideration. You have to understand the environment, and the best way to do that is have a portable spectrum analyzer on site. We'll send technicians often to do a site survey and try and understand the environmental conditions from an RF perspective. The funny thing about RF noise is that it's not consistent, and any spot measurement will not catch everything. I often share this story because it was live for us. We worked with a large appliance manufacturer, and we were seeing beautiful results, putting in their active tag system and making sure that everything worked. And then at certain times of the day, the system would always come down, and we couldn't figure out what was going on. And our user was perplexed as well, trying to send us logs and trying to figure out what was causing the problem. One of the issues, well, there was 3 different issues, and that's what made it so difficult to track down. One issue was automated guided vehicles, and the fact that they were guided with wireless signals. We would have times where they were booting up the entire robotic system, and that chatter would kill the RF band in a very intermittent way. So that was kind of interesting, but that was a little bit easier to control. The second thing on the right-hand side were the guys on the radios. We had people on handheld radios that would come in at very specific times of day. It was mostly the managers that were walking around with those radios. And when we saw their patterns of when they would check in and when they would be supervising the cells, those patterns lined up with those periods of instability in the network. But the third one, which was the biggest issue, and it was for some of the Wi-Fi devices that we had, was the lunchroom. This particular place had the lunchroom right in the middle of the manufacturing cell, and so everyone would gather together for lunch in the middle of the plant floor. And they had 20 microwaves in that lunchroom, and everybody used them at the same time, of course, heating up their lunch. And those microwaves at 2 gigahertz would kick in and really take up a big chunk of the Wi-Fi band that they hadn't isolated. So as you peel back the onion and you start to look at interference, experience shows you different things to start to look for in ways that you can protect against each of these interference points that we've mentioned and several others by segmenting in different bands, by creating different frequencies that you can talk on, and strategies to avoid interference points when you know them. But the key is to know them, and you either do that through measurement or through observation and good requirements capture at the beginning. Many of these things in this application could have been foreseen had we really had a good understanding of the application or had the user considered all of their RF emitting devices and at what times they're active and how they work. Another big issue for us, and I think for everyone in the industry, is chemical exposure. We deal especially in the plant floors, but also out in the yards and on the drilling rigs with all sorts of solvents and lubricants and cleaning agents that we have to survive being exposed to. Many of our products come with many different options of adhesive for that specific purpose. We have to survive alcohol wipe down in the healthcare. We have to survive cutting fluid, on the plant floor. And you can't always do that with one solution. You really have to have some customized or different variations to be able to make that happen. So again, back to requirements capture, think about what you're going to expose these things to. Is it going to be just UV? Is it going to be particular washdowns or lubricants? Think about what happens intermittently, whether it's some cutting fluid that might hit these tags, hit these assets. Each of these should be captured in the requirements capture and then explicitly tested out as part of your project. Again, we offer those services to be able to test that out and create those test reports to ensure that we've got the right chemical resistance matched up. There are cost point differences, of course, and sometimes you have to weigh those out, whether it's worth going to a much more expensive adhesive or even an overcoat or an overlaminate to make that work. Sometimes it is, and you have to have a close look at that to ensure that it's worthwhile versus putting just a simple cap over the top of it. Something that's maybe not chemical exposure, but maybe in the interference noisy part. I'm just recalling this as I think about great applications. We had a lab application where anti-static was really, really crucial. And so being able to coat these tags with a dissipation coating so that it could dissipate electrostatic electricity buildup was really an important requirement in that case. So even if that's your case and you're trying to avoid shock and spark, there are great agents that we can either add as additives to the tag or as overcoatings to be able to dissipate electric shock. Things like that you don't often think about. Now this has been a really big area for us in the last several years, anti-tamper and anti-counterfeit type of tags. You may be in that business now where your harsh environment is harsh because you're worried about people removing these tags and tampering with the assets. You may be part of a supply chain that has to guarantee that you've got legitimate goods coming in. A number of government agencies now are requiring that you can prove that you don't have counterfeit goods as you supply high-value projects like energy sector or reactors. So to ensure that, you need to obviously have a mechanism that you can see that its evidence has been tampered with. There are a number of tags that we offer that have tamper evident features, some tamper-proof features where by removing the tag you break the inlay and you break the contact so the tag can't be read. We have tags that of course can be chemically locked so that you can't remove them, such as that bolt tag that you see at the top. Being able to remove those is just not possible. So these things are possible now in a way that you could make sure that you can't tamper with the tag and counterfeit it. There are a lot of encryption algorithms. So when we think about anti-counterfeit, it's not just about the physical attachment of the tag. That's the anti-tamper features that are well established and we have across the line. To be anti-counterfeit, you can lock and encrypt the tag, and that's important. But also to prevent cloning, which can happen in your supply chain, you need a data solution as well. And at the software layer, being able to generate and encrypt those keys that you give to your suppliers who encode the tags or the tags before they go out, so that even a clone tag will not have the right response, is all very possible in the technology now. And it's something that we're doing now frequently on high-value assets. So if you had not considered anti-tamper or counterfeit in your application, you should. And you should realize the technology is stable and available. Talk to an experienced vendor, and they'll have solutions for you that can take you through that and get a good cost-effective solution for you. So pulling it all together, we've talked a lot about tags, tag attachment, and the way that that works, but none of the tags matter if you don't have the right infrastructure. This really starts with readers and being able to read these different tags. Readers, again, come in many different shapes and sizes. We've put some pictures of ones that we've worked with. We do everything from a Marine standing on a beach with a solar-powered reader that he can stick in the sand and see everything coming off of a boat, which is a really exciting application and doing those, to drones, which are becoming increasingly popular. We do a lot of drone work now, putting small readers up on these drones, scanning a steel yard. For example, that article that was in RFID Journal Live that we worked together with RFID Journal on is a great read, New Age Steel. You can look it up on the site. That drone being able to go out and automatically scan the yard and take inventory of the steel is a real cost-effective way to do it, especially when you're dealing with 45 degree to 50 degrees Celsius heat. Better to put the drone out there than a person. Of course, we deal with lots of handheld mobility devices, as you see in the bottom corner, and lots of specialty gateways, both long distance and short distance, portals and arches that you can scan goods coming through pinch points. So think about your reader strategy. Can you automate it? Can you use something like a drone? Do you need to have a pinch point, like a portal? And think about how you can work that. That can be one of the biggest costs to your project. And then software. There's a lot of good options in software now that there weren't before, both in the handheld side, open platforms with Android that allow you to use consumer devices down on the yard or in the floor, wherever you're doing your asset management, and automatically syncing up to cloud. More and more our customers are moving over to cloud-based computing and being able to do distributed enterprise-class applications. So realize that that's a great option open for you. A lot of open infrastructure that's inexpensive. It does all comply with secure standards like ISO 27001, so you don't have to worry about your data, and a lot of great packages that enable you to do that. So once you put your tagging strategy together, think about how you're going to read all those tags and what your infrastructure will look like, And certainly talk to your vendors about software and decide if you want to host it locally, host it in the cloud, and how you're going to drive the app down on the handheld. All really important considerations that we can help you with, as I'm sure many other great quality vendors can in the marketplace. And with that, I thank you for listening to these applications. I look forward to answering some of your questions.
Thank you so much, Ed. We do have a number of questions. We have about 8 minutes left, so we'll try to get to as many as possible. I have a question here concerning one of our audience members is inquiring about metal cylinders to store various gases, CO2, acetane, that type of thing. He asks, is there a passive UHF tag that is glued to the shoulder of the cylinder that would be resistant to washing it?
Absolutely. So the first thing when you talk about cylinders, and this is a great question, so thank you for raising that. Cylinders are a difficult application because that curvature of the shoulder is very difficult to match. A 4-inch oxygen tube in a hospital is different from a large 20-inch propane tank. And so getting the curvature exactly right would mean designing a tag with that exact curvature for each shoulder. What's more typical is that we use a wet adhesive with a tag that has a slight curvature on the back. So that, by wet adhesive, I mean an epoxy in kind of a tube gun where you would spray a little bit of that on the back of the tag and then press it onto the shoulder. We've done a lot of applications with wet adhesive where that wet adhesive takes up that slight difference in curvature and allows you to get a good chemical weld to the side of the shoulder. So that in general is my recommendation. We do also have tags that will fit that curvature, like our IQ series line. They're a printable on-metal label, and we can have an adhesive that will match the paint that's on your cylinder, or whether it's aluminum or stainless steel or iron, painted iron surface. So either a printable label style or a hard tag that has a curvature but needs a wet adhesive to go on it is the way that you would solve that problem for attachment. There is also an ability to attach up at the top on the collar, but that's less popular because of its obvious interference with different attachments to the cylinder and its ability to be knocked off as the cylinders kind of crash around. So I would really advise the listener who was asking that question, an off-the-shelf adhesive is going to be your biggest problem there. Don't use just an off-the-shelf adhesive. Use a wet adhesive, usually a good quality epoxy. Look for a recommendation from your vendor that can give you an epoxy that will fit your surface, depending on what the metal is in the paint, and then test it. And it's very possible, very doable.
So we're getting a number of questions concerning tags and how well they do in cold environments, specifically liquid nitrogen settings, -80 or lower. Also, another one of our audience members asked about very cold temperatures, such as -80 centigrade, using passive UHF adhesive tags. Or he asked, are there special adhesives that will handle this type of environment?
Right. Yeah, that's another great question. When you're talking about very cold temperatures, and we'll say below -60 degrees centigrade, because that's really where the cutoff is for a lot of the standard commercial adhesives, you're talking about a specialty design, a cryogenic design. And so long as that temperature is the temperature and you're not cycling, you can tune your tag and your materials, both your adhesives and your RF, so that it can operate in that environment, -80, -100. There are cryogenic applications that are very doable. The challenge is if you're getting cycling. If you're going to go from that up to a +25 or a +30 Celsius, that's a very difficult application, and I'm not aware of tags that can really do that cycling in the marketplace. But yes, it's certainly possible to have freezer tags or cryogenic tags that just live at that temperature and operate well at that temperature.
We've got another question that sounds very specific. If you're running material through a shredding and separation system, could RFID tags survive the shredding and be able to track the different outputs?
That's a great question. So a shredding and sortation. So shredding obviously is something that we deal with a lot in our IT data center space, where we need to be able to shred materials to prove positive destruction. So I guess the answer is it's easy to have a tag be shredded and be destroyed, and that's typically what's being asked for. In the sortation side, we've had to design very specific tags that can go through sorters. A great example of this is what we call our corn tag. We have the need sometimes to verify seed, and we've designed tags as small as a kernel of corn that can go into a seed bag, so you can validate that that is valid seed that came from the right farmer, and it's not a counterfeit or non-organic or mutated seed. And that's specifically so it will also go through the sorter the same as the kernels. So yes, it's very possible and is done, making tags that will fit the size and shape of the other assets it's amongst, so it'll go through the sortation and filtration. For the shredding, it's just about making sure that the tag can be shredded and not damage the shredder, and of course not function once it goes through the shredder. And we do that a lot in IT assets specifically.
Okay, we have about 2 minutes left, so let's see how fast you can talk.
Okay.
We have an interesting question here. One of our audience members is, and it seems very reflective of the audience, is interested in the oil and gas industry. He's looking for information regarding tags in harsh environments for oil and gas, such as salt water, oil, that kind of thing. Can you speak to that in a short period of time?
Yeah, for sure. Salt water is a real big contaminant. So one way to do it is, I know we have limited time here, but if the listeners would go on our website, we have a number of case studies there, including on cylinder tagging, as we just mentioned, and also some oil and gas oil platform case studies where you can see how we've dealt with that. Also, you've got my contact information on the slides, and you can email me, and I can give you some specific guidance. But the key to salt water is having a sealed encasement, sometimes with an overmold, sometimes with a potted type compound so that the salt can't get at the core components. And having that done properly and tested is the key to avoiding the salt water or salt vapor.
Okay, well, thank you very much, Ed. We really appreciate it.